Good afternoon, everyone. This is Sarah Parker, and I'm going to be going over assignment 3 for machine learning. This assignment was a little bit different. So we were given a data set that consisted of 28 by 28 sized input images of cats and dogs, and we're asked to use a neural network to transform them into a higher resolution 56 by 56 sized image. So this was basically a 2x spatial upscaling. This network was trained and evaluated using the Google Colab with an NVIDIA T4 GPU, which based off the instructions initially I thought it was going to take a long time to run, but I think because it uses the GPU now, it probably took me like 5 minutes, which was significantly faster than expected. But anyway, the data set used the dogs and cats, and it had 25,000 training images, 12,500 test images, and they were in a JPEG format. They were various pictures of dogs and cats in different poses and a variety of settings. Since we weren't using attempting to classify the animals, this time we were actually just trying to upscale them essentially. They were labeled, but those were ignored. And per the instructions, it said we could use grayscale because that tended to have better outcomes and reduce the training time. So I did use a grayscale, which was just one channel. And then all the pixels were normalized 0 to 1 by dividing by 255. So this was the architecture. Basically, we have like these encoder levels. So we have feature extraction and our output shapes. We used ReLU and Sigmoid, and then we upsampled them. So we basically took it down to a 7 by 7 image and then upscaled it until we could get to our 56 by 56. The training configurations that were used were the mean squared error for our loss function, Atom for our optimizer, ReLU for our scheduler. We did a batch size of 128 and 30 epochs. This was using the T4 GPU on Google Colab. And like we said before, it had 25,000 training samples. So I'm going to jump over to Colab real quick so you can see the code. Okay, so to start off with, the first little problem that I had was trying to figure out how to download this data set, and it turned out that it was in a 7Z format. So we used GDown to just download it directly and then save that into the Colab local directory. So every time the code runs, it will have to re-download, but I just found that this was easier than trying to save the 7Z into a Google Drive and giving access so that other people could run the code as well. So this just shows that it did download it successfully. I'm not going to re-download it now because that will take a while. These are our parameters. Our input size is 28, output 56. We are doing a grayscale. Our batch is 128 and our epochs are 30. And this is just making sure that if the GPU is available, then we use it and we want to see what it's doing. So this is just unzipping the folder and saving the images in the right directories. And then it's defining how we load our images based off the input size, output size, grayscale, and then setting our arrays. So we have our training data and our test data. And then this is the architecture walkthrough for our grayscale. And this isn't code, this is just markdown just for visualization so that you can see. And then this is where our autoencoder is defined. So we have our different layers that takes us down to our bottleneck, our 7.7, and then we decode it and bring it back up to a 5656. This data set does have ground truth, so we're able to see what our 56 by 56 looks like compared to the ground truth 5656. And so we'll keep going down and you'll see that here in a second. We have our training setup. This is using our Atom for the optimizer. And this is just confirming that we did have the right number of samples that are being used. Like I said, it was running really fast, so I just wanted to make sure that we had all of those. And then we run it for 30 epochs. And for 30 epochs, you can see that this actually model performed really well. We started out with a loss of 0.009. And then right around the 15 mark, we kind of stabilize at the 0.002, and it just slowly improves from there, but this is where the model stabilizes, and we get really good results. So I will go back over to the report just so you can see it a little bit easier. So this is our training loss. This shows that, like I said, we went from 0.009 down to 0.002. This is a reduction of about 73.5%, and this is what that would look like. So you can see that steep decline, and then it stabilizes right around that 15 epoch mark, and stays pretty consistent down to 30. And these are the actual epoch numbers. So then what we really want to see is that all of that looks great, but what do our images look like? And so we picked some random images and compared them. So the top row represents the images that were formatted in 28 by 28 in the data set. The middle row represents what our autoencoder upscaled them to as a 56 by 56. And then the ground truth is this bottom layer, what the images actually look like at 56. And so you can see that our autoencoder did a really good job. There are definitely sharper features in the ground truth. You can see like eyes and nose a little bit more clearly, but compared to the 28 by 28, ours definitely has improved features. There's smoothing, it's less blurry, you can make out features a little bit better. You can see kind of on this one, I think he's sitting on maybe like a cat tree. That becomes more sharper and clearer. You can see the tail better. So our autoencoder actually did a really good job of getting images that represent the true ground truth image. And this is just kind of a deep dive comparison on a single image. This was the 28 by 28, which you can see is just very pixel grainy. You can't make out features. This was what our image generated. You can definitely see more that it looks to be probably a dog. You can see the tail, you can see its legs more sharply, you can see the color variations kind of starting to separate here, and ear is more clear. And then that is the ground truth, and you can see that it is still clearer compared to ours, but they're pretty comparable. You can definitely get most of the features that you're looking for. So that was assignment number 3. Like I said, we just took images and we used our autoencoder to upscale a 28 by 28 grayscale image up to a 56 by 56, and this worked out really well. Really the only difficulty was downloading it in the 7Z and then just confirming that the model was running appropriately, because it ran a lot faster than I expected it to. But overall, this was our assignment 3 for an autoencoder for image upscaling. Thank you.